All right, testing, 1, 2, 3. All right, I'm going to give you just a real quick demonstration on using markers and timers. They're a little bit funky using the AGV simulator and in MicroBasic script. So let's talk a little bit about markers and timers. The first thing when we're talking about markers and timers is we're going to work off the same kind of things that we've been doing in the past. Tape detect will be MGD, get value MGD. Tape position will be get value MGT. We don't need to, I don't think we'll need to use left position and right position at this point, so I'll probably just use tape detect and tape position. Marker left would be get value underscore MGM1. That's if I'm looking at the left side, like this AGV is going to here. Or marker right, if the marker was on the other side, get value underscore MGM2. Now, what is a timer in MicroBasic? So there are 4 configurable timers. These are 32-bit timers, which means we can go up to 2.147483 647 milliseconds. So it's a long timer, right? You're talking about 2 billion milliseconds is 2 million seconds is, so do the math on that. It's a long period of time, longer than you'd ever have to worry about timing. The beauty is we want to use timers. The wait instruction is fine, but remember what a wait instruction does. A wait instruction pauses program execution. And when we're working with the actual motor control, the motor control has a watchdog timer. And so if it's not receiving any commands within the code, it will actually fault out. And that's on purpose, right? We don't want some unknown thing popping up all of a sudden. So we've limited the watchdog, I think, to about 2.5 seconds. So you could use a wait command, but you could only use a wait command for, a second or maybe a couple seconds. Beyond that, you're approaching the watchdog timer and potentially faulting out the controller. What's different about the timers in MicroBasic? So this is kind of how we set the timer state. Set timer state. You'd put the index of the timer. So if it was the first timer, it'd be, parenthesis 1, comma, and then you'd set the state to a 1 or a 0. If you set it to a 0, this is where it always kind of gets me weird. 0 means it's running. So when I click it to a 0, basically when I set the state to a 0, it's going to start counting down from whatever its normal value was, its time value. And then state 1 is going to be when it's stopped, and that includes when it reaches its final count. So if it goes from like 2,000 milliseconds down to 0 milliseconds, it would be at a state 1 until you start it. It would be at a state 0 when it's running, 1999, 1998, all the way down to 5, 4, 3, 2, 1, and then down to 0 milliseconds. And then it would go back to a state 1 when it's timed out. If you want to read that timer state, really easy to do. You can get the timer state. So this could allow you to look at it for troubleshooting purposes. And then beyond that, we also can, let me see here. I guess I don't really have a good example. Oh, here's a decent example. So like if left marker is true and timer 1 equals 1,000, then set command, throttle to 0, throttle and steering to 0, and set the timer 1 state to a 0. So what that's meaning is, hey, start timing, right? So I'm starting out at 1,000, start timing. Else if left marker is true and the timer's above 0, I want to stay stopped at that point. And then else if left marker is true and the timer gets down to 0. So now if the count gets all the way down to 0, go ahead and start throttling off of this. So right now my vehicle's not on there, but there would be a point. I guess maybe I can actually run through this, I think. Let me see here real quick. There we go. So hopefully you can see this right now. The vehicle gets to here, and I was here. So left marker is false. The timer 1 state is stop. The timer 1 count is 1,000. The throttle is whatever the throttle is, 500 or whatever the number is. I get to here. The left marker is true. The timer is going to start timing because I'm in that second condition of the else if statement there, right? Initially, the timer counts 1,000, but it's starting to count down. And it also has set the throttle and steering to 0. I'm actually in the first, I'm in the first one there. If left marker is true and timer 1 equals 1,000, stop the vehicle. Now, the next one is I've started timing down. I'm still above 0. But my left marker is still true, and I'm still above 0. I'm at 900, I'm at 800, I'm at 700, whatever it is, I'm counting down. I want to maintain 0. So the timer state is a 0, still timing. The timer count is 500. The throttle is 0. Good, good, good. I'm going to get down to the point where the left marker is true and the timer 1 is timed out to a 0. So when it gets to a 0, you can see right here, else if left marker is true and timer 1 equals 0, then I'm going to go ahead and turn on the throttle and steering again, but I'm going to set the timer 1 state to a 1. So now my timer 1 state is stopped again, and I'm ready to jump off of here. And then now I'm driving off, and eventually I'm off the left marker, and I'm driving down my way, and everybody's happy here, right? At that point, I'm going to set the timer count to 1,000 because I'm off the strip now, and I don't care. So that's going to be kind of my reset. So let's kind of look at what this would look like in the code. So we'll start off all of our code with option explicit. And then I'll do DIM. I'm going to call this timer 1. And then DIM, I'm also going to call this timer 1 state, because that's going to be both important for me to read the timer value and the timer state. So it's kind of like in the world of PLCs, we'd say that we've either enabled the timer or we've not enabled the timer, but then we would have the timer accumulated value that we'd be looking at too, right? So timer 1 state's kind of like a done bit. And then the timer 1 value is going to be like the accumulated value. And then I'm going to do my define in memory. Oop, and I forgot to do something on all of these here, but I'll do this here in a second. Left marker. I'm going to do left marker as a Boolean. I got to go back and do the ones above that. I forgot to label those for you there. So timer 1 will be as integer. And timer 1 state will be as an integer as well. All right. And then define in memory tape position, because we want to be able to drive this thing, right? And I think I actually made these small here. Tape position as integer. I'm going to make my little t's here. Little t. I always like to start the first word with a lowercase, and then that uppercase kind of marks the transition from one word to the next. Then I'll define in memory throttle as integer. I'll define in memory steering as integer. And then I'll define in memory my P gain, which I know I'm going to need at some point, as an integer. And somehow I got my, forgot to hit enter there, so I got to put that in there. So I now have defined my variables. Reminder, I do like, didn't do this here, but I do obviously prefer you guys get some program level comments in here. You know, the programmer name, breaking my own rules here. So I'm going kind of fast. Maybe the project that you're working on. So I'll call this project week 7, or I'll call this my timer lecture. And maybe the date. All nice things for somebody looking at your code in the future to know what it is that you were up to there, what it is that you might have been working on. And I didn't have my numlock on, so it's messing it up pretty good here. So let's fix that. There we go. Feeling pretty good about that now. All right, so there I've declared my variables. I might even tie that off and say, let's actually say that's what we're doing. Let's declare the variables and tell people that that's what we're doing. And then on the next one, let's tell them what we're going to initialize them to. The only thing about initializing variables is what it does is it keeps you from potentially not knowing where your variable's starting. So it's like let x equal blank, right? So for me, for this one, I'm not going to vary the throttle, but I am going to start the throttle off at 500. Hope that works. I've done this quite a bit. P gain, please know that I always screw this one up. I'm going to guess. It's different. The simulator, it's either positive or negative, and on the actual AGV, it's going to be the opposite. So just know that that's coming. But for me, I think it's negative in the simulator, so I'm going to go with that. I'm going to set the timer count, and I'm going to set that timer count of timer index 1. That's the first timer. I'm going to set it to 1,000. So set timer 1 count. That's like setting the preset value of that timer. I want to start off at 1,000 milliseconds. I'm also going to set the timer 1 state. This is the important one to remember here. This is what gets, which usually is the one thing that goofs people up. I'm going to set the timer one state. So the index is 1, comma 1. So it means timer 1 set to state 1. Set timer count 1, comma 1,000. Set timer 1 to 1,000 preset, 1,000 milliseconds. What's goofy about this is, and I almost like to put this over here just to remind myself, 1 equals stopped, because it is a little goofy to me, and 0 equals running. This is going to be handy later on when I'm going to need to remember those things. And then I'm actually going to say timer 1 state equals get timer state. And that's for timer number 1. So I'm going to go read that timer 1 state when I get a chance as well. And I can see that I already did the no there and put the wrong caps in there. So that's initializing my variables. I've declared my variables. I've initialized my variables. And now I'm going to go through my main routine. My main routine is going to be go sub, read inputs, go sub, execute program, go sub, diagnostics, and then go sub, update outputs. And then I'm going to do a small wait in there of like 10 milliseconds. I don't need to update this, at the processor speed. And then I'll go to top. And that's my main routine. So this is like my main routine. So now I need to define those subroutines. So this is redo, read inputs, execute program, diagnostics, and update outputs. So now the next thing I'm going to do is I'm going to actually read those inputs. All right. So that's going to be my main subroutine, or my first subroutine here. Read inputs is going to be, I'll call this timer 1 state. And actually, I could do it right here. I don't know why I did it up there. I don't think I need to do it up there. Trying to think there's a reason why. I don't think I need to. I'm going to take it from up there. I'm actually going to move it down here. So timer 1 state equals get timer 1 state. That's going to be my reading and my inputs. And then I'm going to hit timer 1 equals get timer 1 count. Get timer count. Get my syntax here right. So get timer count, and then in parentheses is the index of the timer I want to read, which is timer number 1. Also in my read inputs, I'm going to have tape position equals get value. I got to remember these off the top of my head. Parentheses underscore MGT. For the tape detected, be MGD. And then I want to get left marker. And again, you can look these up in previous lectures. Or actually, I started out this lecture with this as well. Get value underscore MGM, comma 1. 1 means I'm going to be looking at the left side for a left marker, and then I'll hit return. So that's going to take me out of that subroutine. Feeling pretty good about myself there. Now I'm going to go into execute program. So that's my next subroutine I'm going into, execute program. And in execute program, first thing I'm going to do is I'm going to do my steering command. My steering equals a typical thing we've done before, tape position. And we typically multiply that by P gain, which we set to 1,000 in this case. And then we divide by 1,000. Or no, P gain was 4,000, I think it was. Yep, negative 4,000. And we divide by 1,000. And then underneath execute program, I'm going to kind of set up my nested else if. So if left marker equals true and timer 1 equals 0, then, and the then for that is going to be, let's think here. Let's do a throttle equals 500. So I'm kind of taking control of the throttle here. So if the left marker, hold on a second here, let me think real quick here. If left marker equals, let's think here, left marker equals true, and timer 1 equals 0. So that's going to be the case, that would be the case where the timer is timed out. So I'm sitting on the left marker and the timer is timed out. This would be what would drive me off of the strip. Probably not the route I would go initially. I probably would say if left marker equals false and timer 1 equals 1,000, then throttle equals 500. So basically, I don't see the left marker yet. Keep going forward. No worries. Okay. Then I'll say else if. So now we're going to get a left marker equals true. If left marker equals true and timer 1 state equals 1, meaning we're not timing yet. That means we're not timing yet. So basically, I'm on the left marker, but I'm not timing yet. Then I'm going to say set timer 1 state, which is going to be, I'm going to set it to start timing. So set timer 1 state to a 0, which means start your timer, okay? All right. I also, at that point, there's no reason I can't also say throttle, probably a good idea to do this, throttle equals 0, steering equals 0, and just have both of those good. So I'm basically going to say, no, I want to stop the vehicle is what I want to do. Then I'll do an else if, timer 1 state equals 0, because now I'm in the timer 1 state of 0. I just set it. So I was driving forward, no left marker, hit the left marker. I'm in that second condition now where left marker is true and the timer isn't timing yet. So then I set the timer 1 state to a 0, which starts it running. So now timer 1 state is 0 and timer 1 count, or timer 1 for that matter, is greater than 0, meaning I haven't gotten down to 0 yet. Then I just want to continue doing what I'm doing. I probably will just keep these two. I'll probably take these throttle and steering. It's probably a little overkill here, but I'm going to go ahead and do it. Maintain throttle 0 and steering 0. Okay, just continue doing what you're doing. And then finally, else if left marker equals true. Let me think here real quick. Yes, equals true. So I'm still on left marker, but my timer is timed out, and timer 1 equals 0. Then at that point, I want to go back to my normal throttle. Throttle equals 500. And I'm going to get my steering command from up above, so I shouldn't have to worry about that. But I also, at that point, left markers equals true and timer 1 equals 0. Then throttle equals 500. So I need to reset my timer too, right? So I could do a set timer count equal timer count of 1 to 1,000. Set timer state 1 to a 1. And then I would do my end if. That's my space there, sorry about that, and then I do my return. So what I think I have now is all right, so if I'm not on left marker and the timer 1 is still at 1,000, just keep driving forward like normal. If I get to left marker and I haven't started timing yet, then I'm going to start timing and I'm going to set the throttle and steering to 0. If the timer 1 state is at 0, that's the state I'm in now because I just set it to 0 here, and the timer 1 hasn't reached 0 yet, meaning timer 1 state is go ahead and time, but you haven't gotten down to 0 yet, then keep it at throttle 0 and steering 0. Else, if left marker is true and timer 1 equals 0, if I get timer 1 equals to 0, then throttle equals 500 and set the timer 1 count to 1,000 and the timer 1 state to 1. I am a little concerned here. I almost want to think that this reset is going to occur when I get off of that strip, meaning I'm going to say only do that. The reset will be when I'm off the strip. So when the left marker goes false, this is what will actually reset the whole deal. So I think I'm good here right now. So now I'm going to go down a little further. Under diagnostics, I'm going to print, and we'll do quotation mark, left marker, equals, quotation mark, comma, left marker. And then we'll do I don't need throttle. I can tell if it's going or not. I'll do timer 1 state. I think that's a good one. I will do quotation, timer 1 state, equals, quotation, comma, timer 1 state. And I think I probably also want to get the timer 1 count. So let's get another one, quotation, timer 1, equals, comma, timer 1, and then comma, and then quotation, slash, return, quotation, boom. All right, so that'll print to the debug window though, so I can do some troubleshooting if I need to. Then I'll do a return. The last one's going to be pretty easy because all I'm going to do is basically be driving my motor. So update outputs, and I'll do a set command. I'll do underscore G, comma 1, comma throttle. And I'll do a set command, underscore G, comma 2, comma steering. And I think I'm good there. I'm going to do a return real quick so I don't forget my return statement there. I think I'm good. I'm going to grab all of that code real quick and take a stab at it and see what happens here. Let's go in here, go out of there, go out of there, and go into my AGV simulator here and bring in my code. All right, so here's all the code. No, yeah, I think I posted that in. Yeah, that's good. Just double check there. I'm going to do a build real quick, see if I don't have any warnings. That's amazing. So let's see what happens when I run this. It's driving. You can see your timer 1 state. I'm going to pause it here for a second. Left marker's false. Timer 1 state equals 1, meaning not timing. Timer 1 count is at 1,000. It's going to pause. It's going to stop. It's counting down all the way down to 0, but it never went. So right now I'm at left marker equals true, timer 1 state equals 1, and timer 1 is 0. So let's see what that's doing. I do think I know what's causing that. Let's do it one more time here just so I can get a snapshot of that. Again, I should have paused it there when it got there. Okay, left marker true, timer 1 state 1, and count is 0. 1, 1, 0. Left marker's true, timer 1 state equals 1. Oh. I might be able to fix this with a real quick and timer 1 greater than 0 and timer 1 I think so. That was the state I was in, which was keeping me stopped there. I couldn't get back to here until I get off the left marker. So here, if left marker is true and timer 1 equals 0, I couldn't get down to here because I was stuck in this state right here. I think this may take care of it. I'm going to grab this else if statement real quick and drag that in there. I just put in an extra piece is all I did. And it was this guy right here where I added one extra piece. So now if left marker is true and timer 1 state equals 1 and timer 1 is greater than 0, which it would be, let's try that. Driving again. Timer 1 is definitely greater than 0. There it's counting down, counting down, counting down. Drives off. And there we go. Timer 1 state equals 1. Well, it worked. I don't know why I didn't get my timer 1 back to 1,000 there. I would have liked to get timer 1 back to 1,000. So let's see when it comes off of there, see why we're not resetting our timer 1. So now we're at false 1, false true 0. Go back into here. So now we're at false. Oh. So now I'm here. So if left marker is false and timer 1 is 1,000. So maybe I do want to try to, I don't think I want to reset this guy here. Let's try it though and see what happens. I think that might be a reset a little too soon. I feel like I need one more in here. Like I need a statement like this. I'm actually going to just do it because I'm going to do one more statement here. Else if left marker is false, meaning I'm driving off, and timer 1 equals 0. So it was true and timer 1 equals 0. That got me driving off. Else if left marker is false, meaning I've gotten off the strip now, and timer 1 is 0, keep my throttle at 500 and reset everything. I think that's going to take care of it. So this is just another little statement or another condition I put in down here. Let's see how he holds up. He went in right underneath here. We'll do a quick build on that. Likes it. All right, so we're false 1 and 1,000. Now we're true and we're timing 0. We're down to 0, we're driving off, and then we reset. So now we've got all of the individual cases. When you think about this, what you're thinking about is, what's my status right here? I'm not reading the left marker. My timer 1 is paused. My timer count is 1,000, right? Okay, now I'm going here, going here, going here, going here. This will be my next condition. So the first one was false, 1 and 1,000. Now the next condition, you only saw it for a split second there. Left marker true, timer 1 state 1, and timer 1 count 1,000. That condition is what actually changed the timer 1 state from 1 to 0. So you can actually see it was only there for a split second, right? And now all of a sudden I'm in this state, which is left marker true, timer 1 state 0, and timer 1 count greater than 0. Now I'm going to count all the way down towards 0. I'm going to pause it. This is another state now where left marker is true, so I'm still on the marker. Timer 1 state's a 1, paused out, I'm at a 0, but I need to be driving off. And now this is the next state where I went false 1 and 0, which I'm off the strip now, which allowed me to reset it. And now I'm back into this state, which is false 1 and 1,000. So you can see all of those conditions of that nested else if statement all coming together to make this timer work. The big takeaways on this, if you take nothing else away, the things to remember here, that's really kind of goofy. The timer 1 state, 1 is stopped, 0 is running. That's going to be the key to your success on this. All right, so that concludes this. I hope you guys are watching this and hopefully getting those AGVs out on the track. Thanks.